So step one, we need to verify that our cluster is in the ready state or not. Excuse me. So what I'll do, first I log in with the root user and then kubectl get nodes. So all the nodes are in the ready state. So in yesterday's lecture, we talked about the taints and toleration. Basically, we were talking about that how to assign the pods to is specific worker node. So when we were basically talking about that at that time, we have seen that few topics, means last two lectures are basically like that: node name property, node selector, and then node name, node selector, and then node affinity, right? We have discussed this one. Then we have discussed about the pod affinity, okay? Pod affinity. Then we discussed about taints and toleration. These every topic which is in the Kubernetes is very important. So one or other way it is related to your advanced topics. I would say that these topics which we have discussed yesterday, it comes especially after node affinity. So this comes in the advanced level only, taints and toleration. Okay, so try to as much as practice you can do for these things, because these are not easy to understand, but when you practice it, it will be easy only. All right, so now today we will discuss about one thing which is called the kubelet service. So in the Kubernetes architecture, I have explained you kubelet is basically, it's a service which is running on worker node and master node both, but especially I'm talking with respect to worker nodes. So this is a service. Now, what is the job of this service? In master node, there is a API server. Now, API server is the one who takes care of all the activities in the Kubernetes. For example, you want to create a pod, you want to delete the pod, you want to do whatever activity you are doing in the Kubernetes. So that is basically managed by the API server in the control plane or master node. Okay. Now, consider you have executed a command to create a pod, kubectl run pod and the pod name. So that request to create the pod goes to the scheduler, and scheduler is the one who will decide where this pod will be created. So consider you have given a command to create a pod, and that pod is to be created on some worker node. So that request goes to the API server. Scheduler will say, okay, it will be created on the worker node 1 on the basis of certain statistics. So it checks, okay, which system is less loaded. Let's create that pod on that particular machine, until unless we are having certain conditions where we are bypassing the scheduler, like node name, node selector, right? So apart from those things, by default the pod will be created by the API server, and scheduler will decide where it will be created. It can be created on worker node 1, it can be created on worker node 2, and so on. And every worker node is having a service which is called the kubelet service, right? Now, what is the job of this service? Now, API server send that request, okay, worker node 1, scheduler has asked me to create a pod on this particular machine. So API server sends the pod specifications, and that specification goes to the kubelet. Now, kubelet duty is that on the machine worker node 1, it will create a container with the whatever the pod specification we are having. For example, we are creating the Nginx. We are creating something called Nginx pod. Okay. So now when this pod get created, right? So then uh, Nginx pod and Nginx container, right? Because pod is monitoring the container. And this all activity is done by the kubelet. So it means the instruction came from the API server to kubelet, and kubelet is running this on the machine. Let me just show you that one. So I will go to my master server, and if I say kubectl get pods, so you can see no pod. Now I will create a pod, kubectl run pod 1 with the image Nginx. So pod get created. Let us see where it is created. So it is getting created on worker node 1. Let's wait this to be created. Now this is created. Now if I go to worker node 1, right, and here if I say sudo su, so we are running the container. Just one second. I'm unsharing for a minute. All right, so I'm back. Okay, so now what I was doing, I have created a container which is on worker 1 get created. Now if I go to worker 1, and here we are running the container. How do you know that container is running? So ctr and containers list. Okay, so if I run this, ctrs, what is that? Ctrl container container D, right? So let's because I never worked on container D. So let us see how we can see the uh, containers. Okay, so container D and list containers, right? So we'll see that command. So it is okay. This is containers CTR only, container list or ls. Okay, so it is not showing. This is looks like it's not a ctrl containers or ps command. Just let me just check on what is the command for the container D especially. Okay, let's open the chat GPT and I'll say container list in container D worker node Kubernetes. So the command is CRI-CTL. Okay, so this is the command. So I'll say CRI-CTL and PS minus it. Okay, so now here you can see my pod 1 is running. See, pod 1 is running, and this is my container which is running with the Docker image. So here you can see this is the, well, let me just decrease the zoom, right? Now here you can see this is the name of my pod, and this is the container ID. This is the I think I need to reduce a little bit more so that it can be easily. Yeah, now it is, you can see. So this is my pod 1. See, it is running on this machine, and this get created. This is a container. Okay, this container get created and on that particular worker node machine. If I say CRI, CTL, and images, okay, so here you can see this image, right? Here it is showing the image ID 204, and that 204 image ID is the image ID of the Nginx only, right? So it means this container is running on this particular machine. Who has created? Kubelet has created. Now, if I say, are you able to see properly this screen? Actually,
Yes, sir. I can see
yeah,
that.
because I want to show in a column wise. Otherwise, that wrapping is happening, so we cannot see the value under that particular column. All right. So now, if I say here, um, let me delete this particular container. Okay, let me delete this container. So now when I'm going to delete this container manually on worker node, then kubelet is basically keep watching that whatever the pod specification I have received from the API server, whether the container is running with that specification or not. If it is not, then it will create that container again. Let us try that. Now I think the command will be CRICTL and rm -f and the container ID. Okay, so it is saying stop the container from the runtime. Okay, we'll stop that first. We'll say kill or stop because container D commands are different from the Docker command. Okay, okay, looks like it is stopped. Now I'll say CRACTL, remove this. Now this is removed. Now if I say CRICTL and container list, right? So you can see that container which is having the container ID 960. Is it here? I don't see. This is removed. But a new pod get created or new container get created when 32 seconds ago. Who has created this? This is created by the kubelet. Because kubelet is keep watching that whatever the pod specification I have received from the API server, so whether my containers are running with that specification. Now what I have done, manually I have deleted this particular container. Now kubelet is watching, oh, that container is not running, and this is the API specification, and it is to be running on this machine, and it creates that on the basis of the pod specification. Now let us do one thing. Let us delete our pod here. kubectl delete pod and pod 1. So I'm deleting this pod. So this pod get deleted. Now the container also get deleted because now kubelet received one more signal that, okay, delete this container from the API server. So it is obeying the order of API server. Now, if I say docker ps -a, and you can see pod 1 got deleted, right? So this way, the kubelet service is working. If I say systemctl status of kubelet service, right? So you can see that this is a service which is active and running. So this way, right? So this way we are basically getting the information or kubelet service information, whether it is running or not running. If it is not running, there will be a problem. You will not be able, because it will not monitor the containers running or not, or there are some other activities which kubelet service is doing. It is like an agent on that particular machine. Right? Now, so now let us talk about one more type of pod, which is called static pods. Static pods. So what is static pod? Now, API server is creating the pod and it sends to the kubelet on that worker node. And on worker node, kubelet creates the container. Right. Now, consider you want something to be managed on the worker node level. See, whenever APIs server get the signal from the scheduler. Now scheduler is saying, okay, create this pod on worker node 1 or worker node 2. So API server will send that specification to that particular kubelet, which is running on that particular machine. Now consider there is a worker node 1. And on worker node 1, you want to run some specific thing like you want to collect the inventory log, you want to monitor the system, which is specifically for the worker node 1. Then what we can do, we can create a pod directly on worker node 1. So if you create the pod directly on the worker node 1 and it is to be created by the kubelet service, that is called the static pod. Okay. So let me first show you how we create the static pod. Then, it will be easy to understand the definition. Let us see that one. Now, what I'm going to do here, I'm going to uh, worker node 1 or worker node 2, any of that machine I can go. So let me go to the worker node 1. Okay. In worker node 1, what I'm doing, there is a special type of directory, which is etc, under etc Kubernetes. So if you see here, there is a directory which is called the manifest. Let me go to the master server first and let me run kubectl get pods minus o wide. Okay, so there is nothing, no resource form. Right now, here you can see there is a directory. I'm on worker node 1. You can just check the host name here. Okay, I'm on worker node 1. So now, if I go to this manifest directory, now there is nothing inside this. Let me go inside this directory. Now I will create a file, say nano and pod1.yaml file, or I will say worker node 1 pod. Actually, I'll say pod. What I'll say monitoring pod. I'll say okay, monitoring pod.yaml file. Okay, so I will create a pod. See, so far we have executed all the commands on the master node, but I am on the worker node at this moment. So I'll simply say API version, which is v1, and kind is pod, and metadata. And here I will say name of the pod is, I'll say worker node 1 monitoring pod. Or I will say simply, I will remove worker node 1. Okay, I will show you that worker node 1 automatically get added. And now I will say specification. Under specification, I have the containers. Consider you are running your monitoring container, but I don't have that image. So I will simply say Name of the container is monitoring, and the image is say Nginx. Okay, it could be some monitoring Docker image, but I'm using Nginx. Save it. Nothing we need to do after that. I'm not running kubectl create command. Now, if I run this, now you can see there is one container or one pod is already there. So few things we need to note down. First thing is that you can see that the name of the pod. So the name of the pod, if you see here, which is monitoring pod, right? This name we had given, but after that it automatically added this part hyphen worker node one. So this is a static pod. This is a static pod because this pod is not created by API server. Who has created it? It has created by the kubelet service, which is running on worker node 1. So that has created. If it is not created by API server, then why it is showing this? So it will be shown by the API server, or you can say it is a mirror copy of that. Okay. Now what we will do, we will see this IP address. This is the pod IP address. Now, if you remember when I was deleting the pod, normal pod, then what was happening? When I create it again, then its IP address gets changed. But here it is not like that because this is not maintained by the API server. Even though if I delete this particular pod, its IP address remains same. So let us check that one. So what I'll do here, first I will take this IP address and I will go to my worker node 1, and here if I say curl and this IP address, so you can see I'm getting the Nginx, means my pod is running and I can access it on worker node 1, right? Now what I will do, I will delete this pod. Okay, so this is the IP, right? Now what I will do, I will delete the pod. Okay, so how to delete the pod? kubectl delete pod, and the pod name, you can give this pod name. Okay, now when you delete, immediately it will be created again. See, it is in pending, but it will be created soon, right? See, the IP address is same, exactly same, and it is in the running state. Whenever I have a pod, if I delete the pod, then all the data inside the pod get deleted. Let me show you that one. If I create a normal pod, kubectl run pod 1 with the image Nginx, right? So pod get created. Now, if I say kubectl and if I say kubectl exec minus IT, right? And the pod name is pod 1. And if I say mkdir and I'm creating a test directory. Okay. Now, what I will do under this test directory, I will create a file, say touch and some file, say new file .txt. Now, if I say ls my directory, right, inside the pod, this is a normal pod. Okay, so you can see there is a new file .txt file, right? Now, if I delete the pod, if I say kubectl delete pod 1, then what it will do? The pod get deleted. So this data also get deleted because pod get deleted. But now let us do the same thing with our monitoring or static pod. So what I will do, I will go inside my pod, which is the monitoring pod. and worker1. Okay, and I will say mkdir and create under root test directory. Okay, so let me just check the name from. So name is this one. Right. So I will say I think problem is hyphen hyphen I missed. So that directory got created. Now what I will do, I will uh, create a file inside this touch, and I'll say test.txt file. Right now, what I'm going to do, I'm going to delete this pod, static pod. So kubectl delete pod and the pod name. So pod is deleted. Right. So now we can check kubectl get pod. So again, it got created 5 seconds. Actually, it is not created. It is taking a copy again from the master or from the worker node. See, IP address is same. Now, if this is a normal port, data also get deleted. But here, the data should not be deleted. Now, if I say ls and under root test directory, so you can see my file is there. Because that file is not on the pod which I have deleted. So when you delete, so you are deleting the copy. You are not deleting the actual pod. That's why this file is there. Now, if you see, the name of the pod is also very interesting. Here, up till here, this is the name of the pod. After that, on which worker node it is running. If it is running on worker node 1, it will be worker node 1. If it is running on worker node 2, it will be worker node 2. Now, another very commonly asked question, that why we need it. So initially I mentioned you that when you are monitoring a particular worker node, create a static pod on that. If you want to access the log of a particular node, then you can go with the static pods. Okay, even though those get deleted, it will be maintained by the kubelet service on that worker node. Now, when we talk about the master node components, etcd, scheduler, API server, those all are the static pods. Let me show you. kubectl get pods minus n cube system. Cube system is a namespace. Namespace is a separate topic we will discuss later. Now, here you can see there is a kube API server hyphen k master hyphen worker node name. So this is running on the master server. Now here you can see etcd kmaster. This is also static pod. Kube scheduler kmaster. This is also a static pod. Kube controller manager kmaster. So this is also a static pod. So all the control plane components which are working as a for the master node, all they are the you know static pods. Now, if these are static pod, they must be in a special directory, which is /etc slash Kubernetes and manifest file, right? So here you can see the definition of all these pods are in this particular directory. So static pods should be under this directory, whether it is worker node or master node. And if someone by mistake deletes or your administrator deletes this particular pod, it will be automatically get created with the same configuration because it is not created by the API server. Let us go to our documentation quickly to understand this one. So let me just go to that one. static pods. Static pod is a pod that is managed directly by the kubelet, not by the Kubernetes API server. Normally, pods are created using kubelet commands, YAML manifest file, or deployment. These pods are scheduled by the Kubernetes scheduler. Okay, if you are not using the static pods, but the static pods are different. So they are created directly on the node and managed by the kubelet, not scheduled by the Kubernetes, okay, or Kubernetes scheduler. Key characteristics of static pods. These are managed by kubelet. These are created on the local manifest file. These are scheduled uh, by itself, means kubelet only, not by the scheduler. It is on a specific worker node and only observed by the API server, not create. Now, static pods. Normal pod, API server, scheduler, and worker node. Static pod, manifest file, kubelet, and then the pod created. Where the static pod manifest files are stored, these are stored under etc, Kubernetes, and manifest directory. This directory is monitored by the kubelet. Kubelet automatically creates the pod if it is deleted, if that particular pod is created, or that YAML file is inside that particular directory. Example, this is the example similar we have created. Create the static pods, right? And if you put your YAML file into this particular directory, that automatically becomes the static pod. You can verify this the way we have shown that. Now, delete the pod via kubectl. I have deleted, it get recreated. Delete the manifest file, pod will be removed. So what will happen? So if I go to my worker node 1 now, right? And here, if I remove this file, if I say rm and this YAML file, now pod will be automatically get deleted. So if I say kubectl and get pods, so you can see that pod get deleted, right? So scheduler not used. Delete the static pod. To delete the static pod, remove the manifest file, right? That I have done. Why static pods are important? These are mainly used by the Kubernetes control plane component, that which I have shown to you. Excuse me. So you can check the control plane with this command I have executed. Now this is the difference between the real normal pods and the static pods. So these are created by the kubelet. This normal pod created by API server. Scheduler is not used in the static pod. It is managed by the local file. It is managed by the Kubernetes. Now used for the system component. This is used for the application point of view. Right. So, yeah. Do you have any question related to static pods?
No, sir.
Okay. Okay. So I hope you understand this concept. Now,
Yeah, I'm getting that.
good. Okay. Now let us talk about the replication now. What is replication? See, let me try to explain with some example. Now, I'll choose just a second. I'll use draw.io. Right. Now, consider that you are having a cluster, right? In Kubernetes, we work on a cluster on it. So this is my, right. So this is my master node, right? This is my master node. And this is my worker node 1. And this is my worker node 2. So there are, our cluster is something like that only. Okay. So now they are basically, they are connected to each other, right? Through the pod network. Right. So there is a pod network, which is so all are connected with the pod network. Now on top of that, we are having one more network layer. On top of this pod, on top of that host machine network, we are having one more network layer, which is called the pod network layer, right? So where is that pencil? Just 1 second. I'm just searching that. Here you go. Line color, and this is the. Let me see. This one is the one. Okay. So this is my. So let me decrease the. So this is my pod, and this is my pod network. So, or we can use direct. This is the pod network. Okay. Now, whenever we are creating the pods, consider this is the pod which I have created, right? And this pod is created on top of this pod network layer. So this is how basically it works. So this pod is created on top of this pod network layer. Okay? Now consider someone has deleted this pod. Someone has deleted this pod. So if this pod get deleted, then what will happen? Then application is deleted, data is deleted, everything get deleted. So when we are creating a pod, we want that because some client is using this, right? So some client who is basically, oh, this is not good. Okay, I need to do a little bit more practice on this. Looks like. Okay, I will use it later. I will go to the MS Paint for now. Okay, that will be much better option. So now this is our cluster. And on top of this cluster, this is in the network. And on top of this cluster, we are having this pod network. And on this pod network, we are having a pod running. Now this pod, if it is deleted, okay, if this particular pod, if it is deleted, then what will happen? Then deleted means deleted, everything is gone related to that pod. But I want that if this pod get deleted, automatically a new pod get created. This is called auto healing also. Okay. So if a pod get deleted, then automatically it will create a new pod. It is not the static pod. This should be created by the API server. Then we use a concept of replication. So when we talk about the replication, there are two types of replication concepts we are having. One is replication controller, one is ReplicaSet. But let us talk about the replication controller first. It is managed by the controller manager of the control plane component. Okay, so controller manager is managing that. Now, in the replication controller, there will be a desired state. Desired state means how many replicas you want to create. For example, you are saying I need to create 3 pods. Okay. And how many are running, which is the current state. How many are running? Consider there is 1 pod running. So what it will do, it will create 2 new pods with the same pod definition. So the pod definition it picked up from the pod template. So we will define a pod template, and that pod template is the one which is basically creates a pod. So pod template is having the pod definition for the replication controller. So whenever a pod is created by the replication controller, it takes this pod template definition. It takes that and create the pod. Okay. So for example, there is 1 pod which is running. So instead of 1 pod, it needs 3. So it will create the replicated pod. Now the replication, how it knows that which pod, right? So how it identifies the replication. So what it will do, it will identify by using uh, the labels or pod labels. Okay. So consider for this pod, I have a label which is app equals to Nginx app. Okay. So now, right. So this pod is created. So I need to create similar pod. So how it will identify that pod with the label app equals to Nginx app. So what I'm going to do, I'm going to copy this particular pod now. Take a copy of this. So this is my first pod, copy and paste. This is my second pod. What is the similarity? It is same because it is having the same label. So label matters. So I want to create 3 pods. So these 3 pods are running with the label app equals to Nginx app. Okay. Now what are the use cases? For example, your pod is running on this particular machine, worker node 1. And now your worker node 1 goes for a kernel update or patching. Then what will happen? This particular machine will be this particular machine, which is my worker node 1. If it is going for patching and if a pod is running without replication, then what will happen? That pod get also it will not be accessible. Okay, but you want if my machine goes for the patching, then the then what it will do? It will basically then it should go to that particular that pod should be created on some other worker node. So that can happen by using replication controller. So if the current state is not equals to desired state, so replication controller make it equal. Okay, so let us take with the example. Another thing is that replication controller you cannot create by using kubelet command, kubectl command. So we need to use the script only. Okay, so let us see that one. So what I'm going to do now, you can use the Visual Studio Code, you can use the Kubernetes documentation. I have already the documentation ready here. Replication controller ensures that specified number of pods replicas are always running in the Kubernetes cluster. If a pod fails gets deleted, replication control automatically creates the new pod to maintain the desired number of replicas. Okay, so desired pod 3, running pod 3. If the pod crashes, desired is 3, replication controller will automatically create the pod to resolve the count. Why replication controller is important? For high availability, for fault toleration, automatic pod recovery, and load distribution. So if we talk about these are the use cases, right? When you need the high availability, you can go with the replication. When you need a fault toleration means if particular application or machine is not available, then other will take the load and manage the application load. So that is basically the fault toleration, automatic recovery, right? So if application is down, a new pod will be created on some other machine. And when we are using the load balancing, we need the replication underneath that. Now, example, web application running with 3. If one pod fails, Kubernetes creates the another pod automatically. Now, let us talk about the replication controller. So replication controller continuously monitor the pod on the basis of the labels. Now component metadata. So this is the example. So if I take this example, here you can see API version kind is replication controller. Name of the replication controller, you can give anything. Now here you mention the replicas. Now replica equals to 3 means 3 replicas I need for this. This is the pod template. This is the definition. So in this definition, what I'm saying, metadata, labels, right? So label is important. Now here, this is my pod definition. It is same as we have created earlier, right? So here I'm saying label app equals to web. Specification containers. So I have the name of the container is Nginx. Docker image I'm using Nginx and it is running on port number 80. So on the basis of this pod template definition, it will create 3 pods. Okay. And this is the selector, which is called the label selector. So now it is how it is monitoring which ports are running on the basis of app equals to web. So it is looking for all the ports which are having label app equals to web. So let's copy this one and let me go to my cluster. Right? Now here I don't have any pod at this moment. Something goes wrong. Okay. My system got disconnected. Okay, somehow. Now what will they? Sudo su. Okay. Now replication controller. Right. So what I'll do, I will go to my manifest directory and here what I will say nano and replication controller.yaml file. As I mentioned, there is no command for this. We just need to use the YAML file only. Now let me save this. Now if I say kubectl and create -f replication controller.yaml file, right? So now this get created. If I say kubectl get pods or get replication controller. So here you can see the name of the replication controller. Actually, name of the replication controller is also interesting because the pod which get created, these get created on the basis of this name as the prefix of the replication controller. Now, desired state is 3 because we have mentioned 3 replicas. Currently 3 are running. One is ready. Let us see again. So 3 are ready. All are ready. And 30 seconds ago it got created. Now let us see kubectl and get pods minus o wide. So there should be 3 pods. See, all are started with the replication controller name and then hyphen some random value. So these are in the running state. 2 are running on worker node 1 and 1 is running on worker node 2, right? And these are the IP addresses of my pod. Now I want to check whether really it is created by the replication controller or not. How do you know? kubectl and describe replication controller, which is Nginx replication controller. So here you can see these are the events uh, which basically takes place by the replication controller. And it is saying, yes, I have created this. See the name 9XLRR6, 9XL, RR6 and third one, right? So all get created by the replication controller only. Here in the describe command, you can see some more properties. This is the pod template, right? And this is basically having the pod status. 3 are running and 0 waiting, 0 succeeded, 0 failed. 3 are the current and 3 are the desired, right? So this is fine. Now What I will do, I will delete a particular pod and we will see whether replication controller will create that pod or not. Right? So let me delete one of the pod. If I say kubectl delete pod and pod name is considered 9XL, I'm deleting. Now this is deleted. Right? Now if I say kubectl and get pod, a new pod should be created. See, 6 seconds ago, a new pod get created. 9XL, this pod got deleted. And this pod is in the running state. Who has created this? Again, we will check the describe command. Right? So here you can see a new pod get created by the by the replication controller. Deletion, it is not done by the replication controller. That's why it is not recorded here. Right? So it will maintain the replication controller maintains the current state equals to desired state. Now, next thing is that how do you identify that all the pods are running with the replication controller? One way is describe command. Other way is that you can first check kubectl get replication controller with a label app equals to what we have given here, app equals to web, app equals to web. It will show all the replication controller which has the label where we are defining here. You can see um, selector app equals to web, right? So this is the one which is having the label app equals to web, right? Now I want to see all the pods which are having label app equals to web. So there are three. Now consider if I create one more pod kubectl run and pod one with the image nginx. So this pod get created. Now you can see here it is not showing pod one because its label is different from the app equals to web, right? So this way we can use the replication controller. You can also say that, if you want to see double equals to, this will also give the same result. Equals to or double equals to you can use. You can use not equals to. Not equals to, it will show all the ports where app is not equals to web. Okay. So pod one is the one which is not the matching label pod, and so it will show all the ports which are not equals to the pod which is having the label app equals to web. Okay. Now you can scale also, scale the replication controller. How to automatically scale that we will see later in our horizontal pod auto scaling. But if we want to scale manually, so scale the replication controller. So if I say kubectl and scale my replication controller, and the name of the replication controller is this one, and how many replicas you want to increase or decrease. So increase means total number of replicas. If I want 5, so it means now 5 pods will be running with the label app equals to web. So we can check that, right? So now you can see there are 5 pods are running, right? Now, if you want to scale in, means you want to make it again 3. So what it will do, it will delete the pods, right, which got created, right? So new pods get deleted, and now here you can see there are 3 pods are running. So you can scale out or you can scale in also. So if you think that if this replication is used in the background of a load balancer and you think that we need we need more replication, so you can scale out that also. And if I delete my if I say kubectl delete replication controller and the name of the replication controller, if I delete this particular replication controller, then what will happen? It will delete the replication controller as well as it will delete the pods which are related to this replication controller, right? So now if you see, all the pods which are related to this get deleted. Only we are having that pod one. Right? Let us go to this replica 3 selector, right? Template. So we have created, I have executed all these commands. We have deleted a pod and we have seen it is running. Scaling also we have seen, and deleting. Limitation of replication controller. This is the old Kubernetes concept and it is equality based. Modern replacement is replica set. So let us talk about the replica set first, right? So what is replica set? So replica set is doing the same work as replication controller is doing. Means current state should be equals to the desired state. But what is the difference? The replication controller is, if we talk about the replication controller, this is equality based. Okay? This is equality based. What is equality based means? It is using the equals to symbol only. Okay? Say an example. I'm saying where label equals to value, right? But replica set can use the set based operator. Okay, set based operator. What is set based operator? So these are something like in operator, not in, exists, the one which we have discussed in the node affinity or pod affinity, right? So those operators can be used. These are called the set based operator, and that we can use in the replica set. Okay, so let us see that one. So here you can see this is same. Why replica set is important? Same way, right? Concept is same. Okay. Now we will talk about this replica set. We will create a replica set. Okay. Same thing as we have seen earlier. Okay. And now it is exactly same what we have discussed. But now here we are using something different. There we have used selector app equals to web. But here we can use the expressions also. Like here you can see labels app equals to web. We can use the in operator. Let me see whether that example I have. Okay, it is not here. Let me just go to the Kubernetes documentation. Replica set Kubernetes. So we'll go to the Kubernetes documentation. And here you can see I have two labels. Let me take this example. This will be more relevant. Okay, no, this is only match labels. I'm just looking for the match expression syntax. Or I have that example. Let me go to my other website, which is devopsworld.co.in. And if I go to the Kubernetes, and here you can see the replica set. And this is the difference which I was talking about. It's a set based, in not in exist you can use. For example, if you are searching something where label app equals to production, here I'm using equals to I can use with the match labels, and match expression I can use something like this. Key is the tier, operator is in, value is equals to front end. Let's take this example. Okay, so this is my replication controller, replica set. Let me copy this and let me go over here. And now I'll say nano and replica set dot YAML file. Now here what I'm saying, this is the name of my replica set. Kind is replica set. Now see the API version is different. Apps/v1. Earlier, so far it was v1. For replica set, it is apps/v1. Now this is the pod template. In the label section, I am creating two labels. You can create one label also, right? But label is must. One label at least you should have on the pod definition because that is a selection criteria. But I use two labels, right? And now here I'm saying the container. This is Nginx container running at port number 80 and match label. So match label is the selector equals to where app equals to Nginx app. So this should be matching with this. And second selection criteria is the where key is the tier. So these labels can be user defined labels. Okay. Key and value pair. So here key is tier, operator is in, and value is front end. Okay. So that is also one of the criteria to find the pods. Now what I will do, I will save this. Now, I will create the kubectl create -f and replica set.yaml. So concept wise, exactly same, whatever we are having in the replication controller. But it is a set based. If someone asks, what is the difference between replication controller and replica set? So you can say replica set is the next generation of the replication controller. Okay, most of the resources in the Kubernetes, they use replica set in the background for the replication point of view. Like deployment uses the replica set, and the daemon set, it is using replica set, right? Like that. So now if I see kubectl get pods, so you can see there are 3 pods are running. That scaling, deleting that part you can try by yourself because you need to delete a pod and you need to see it is automatically coming up. Okay, that thing you can try by yourself. Now I want to show something kubectl describe replica set and the name of the replica set. Now here you can see there are 3 pods get created. Now here you can see the selection criteria. It will check all the pods which are having app equals to Nginx app. So I can say kubectl get pods -l app equals to Nginx app. Right? So see, it is showing all the ports which is related to replica set. Now, second criteria, second way you can use the in operator. Here you can see, I want to see all the ports where tier in front end. Okay, and how it came, because in our code, we have mentioned where tier in front end, right? So we can compare this also. Now, if I say kubectl and get pods where label, and in single quote, you need to mention that tier in front end. It will again return you the same. So we can use in operator, which we cannot use in the replication controller, right? So this is how the replica set is used. And again, you can scale out and scale in. Same, you just need to say kubectl scale replica set, and the replica set name hyphen replicas equals to 5, 3, same way as we have used in the replication controller. So I would suggest those commands you can try by yourself, because it will be the, if you repeat it, then you can, have a comfortability to use these commands. Now, if I delete kubectl, delete the replica set, which is the Nginx replica set, it will delete all the ports which are related to the replica set. So if I say kubectl get pods, see all the ports which are related to the replica set is deleted. Now let me delete pod 1 also, kubectl delete pod and pod 1. Okay, so this is how we use the replica set. The short form is RS, right? Okay. Now replication is having the extension with the deployment, daemon set, and stateful set, right? And furthermore concepts like jobs. So I think for today, we have discussed that static pods, replication controller, and replica set, right? You practice these topics. And if do you have any question?
No, sir.
Yeah, good. Okay. So then let's wind up today's session here. And tomorrow we will discuss about the deployment, daemon set, these two topics.
Okay, sir. Fine.
All right.
Yep. Thank
Thank
you.
you. Bye bye.